Hello, my name is Michael Spratt. I'm coordinating an open data citizen science web project designed to help anticipate plant adaptations to climate change. During this presentation, I'm going to use an Excel spreadsheet to help explain the project. In addition, an Excel spreadsheet provides a working prototype and development tool, which is collaborative and pedagogic, has all the functionalities to perform the calculations, is simple, modular, and scalable, and has many features such as graphs, reports, and interfaces with many other tools. We're using daily weather data divided by latitude and longitude, scientifically and mathematically established plant characteristics, mathematical models, and we're hoping to integrate data obtained from field observers, concerned citizens, intelligent sensors, and satellite images in order to model plant adaptation to climate change over the next 100 years. Daily weather consists of 10 daily weather elements such as temperature, wind speed, precipitation, solar radiation, relative humidity, and others, each for 365 days per year for nearly 10,000 latitudes and longitudes for 147 years starting in 1951 and going to the year 2098. We are also incorporating geological data such as the soil types and their depths, the inclination in relation to the sun, and the slope of the area. We are combining plant phenological data based upon scientific research, which mathematically describes how bud, leaves, flowers, and fruits will mature, plus the effects of drought and frost and the competition from other plants, which will also affect the species' survival probabilities. There is a plethora of mathematical models. Let me give you some examples. Here is a thorn weight evapotranspiration model as described in Wikipedia. Here this model is transposed to an Excel spreadsheet. Here is another example. This is the Penman evapotranspiration model in the Wikipedia, and here it is represented as a spreadsheet. We wish to incorporate and validate as many plant models as are available. Since this is an open online system, we hope to gather and verify as much data, the relationships, and models as are available into an online graphic tool. We wish to include data from field measurements, observations, and satellite images. Our tool should model real-life data and help decide what should be planted before and after droughts, frosts, floods, or fires, what plants work best together, and what happens with insects, parasites, and other fauna and flora dependent on healthy forests. Now I'm going to give a more technical description of the Excel spreadsheet. This will be basically a demonstration to show a proof of concept that an open knowledge, open data internet project is desirable. I want to show how a simple approach reiterating the basic calculations will produce emergent functions which are important to intelligent decision making. All the daily weather and the species data required for the calculations is found in one worksheet called Work. Thus, all the calculations in the spreadsheet are based on one sheet, the Work, which contains the daily weather for 1 year and the data for one species, and all the results are stored in one sheet called the Results. Let me explain how a simple Excel spreadsheet can be used to process big data. Here we have a daily weather sheet. As you can see, we have the latitude, the longitude, the year number, and the day number, and the temperature, the minimum, maximum, and solar radiation. Down below we have the names, weather day 0, weather day 1, weather day 2, and this can continue off into affinity. Let me give you an example. Here we are in the work area with the year number pointing to year 1. This will bring in the daily weather number 1. If we put in a 5, this will bring daily weather number 5 into the work area. So you can see whatever the year counter is, that data will be loaded into the work area. So we have a sheet named weather day, and we have a numeric counter that's being converted to a character and concatenated to the name weather day. So for example, if we concatenate an 8 to the weather day, and this name will become an address with the redirect command, and thus the data in weather day 8 will be loaded into the work area. This technique works also with the results per species, species 1, 2, and 3. A similar technique is used to select the species. By changing the species number, we're able to bring in different species data. Let's quickly scroll through the data concerning the plants. The data required for the evapotranspiration model, the data required to calculate the roots and canopy development, the data concerning the phenology of the plant, the data values concerning how the species will react to frost, to drought, concerning its buds, its leaves, flower, and fruit maturation. All the calculations from the models are stored into one sheet, the results sheet. Excel is being used to demonstrate this application. It's easy to show how Excel can be used for one location, 1 year, and 1 species. I can also show how we can scale up the Excel demonstration to several locations, several years, and several species. The control sheet coordinates the interaction between the species, the daily weather, and the worksheet. So here we have the year number, the species number, and the canopy number. These are counters that will be augmented by a macro command. This is the species section of the control sheet. This is where the user can select which species he wants to model. Every species comes with their own mathematical models. Here we show the macro command executing. It augments the counters, which controls what data is being put into the work area, what data is being stored in the results, and what data is being stored in the results for each species. I will quickly display some of the sheets found in our phenological model. We have the control, the worksheet, the sheet containing the data for the species, the results for 1 year for 1 species, the results per species per year, the results for the bud and leaves, the evapotranspiration models, the strata, which calculate the leaves and the roots, the water-carbon cycle, bud maturity, frost on the leaves and the flowers, fruit maturation, the monthly droughts, and the daily weather for the period. In resume, the goal of this video was to demonstrate an Excel spreadsheet that's easy to enhance by most experts and citizens, that could be easily developed into an open access citizen scientist web application. We need a lot of help to verify all the data and their relationships to the environment, to improve the calculations, and add things like graphs, reports, and other features. As an open tool, the user group can decide which directions to take the application. They can add user-specific data and share knowledge between individuals. Thank you for the time and effort you've taken to review this video. Any help, suggestions, or offers are welcome. Thank you.